We saw previously that binary search is a good method to solve the flight path problem. However, we also realized that the binary search code that we had written previously was about finding a value X inside a list L. And this particular problem, does not necessarily, or let's say immediately fit into this mold. So we have to clearly adapt our binary search function. Here, let's just very quickly review what we had, and then we will change some stuff in this, to make it suitable for the present, let's say, problem at hand, right? Fundamentally, binary search is about, searching the list in the middle, and that's what we'll do. So we have this binary search. I'm just going to call this binary search altitude to sort of reflect that, we are solving the flight path problem with this. So I pass in a list called altitude, and I have a threshold, a thresh. So the whole objective of this, let's say, search is binary search on the list, say altitude, altitude to find the first index where a thresh is exceeded. So that's the sort of the goal for this. We discussed this in the past. Now again, I'll start with the Boolean variable for found, set it to false. I set the low and high pointers in the beginning. As before, we set them to the extremes, so 0, and let's say the length of L, so length of has to be altitude -1. So basically the extremes. In this case, remember, there's a possibility that my threshold provided is greater than or equal to all the values in the list altitude. We are going to check that upfront with before running the. So I'm going to say, well, look, if a thresh is greater than or equal to altitude high. Remember, altitude list is non-decreasing, which means altitude high is really the highest altitude that we have at hand. If that happens to be, let's say, smaller than or equal to a threshold, which is right saying a threshold greater than or equal to altitude high, I don't need to run the while loop at all. I can just return -1 because the flight never crossed the threshold. Now, one point to think about carefully over here is why greater than equal to, why not greater than? Remember, the problem statement is the first index where the threshold was exceeded. So that's why, and that's the answer. Yeah, happy to discuss. Now, having done this, clearly, as earlier, we have this variable found which controls the way the loop runs. And then we are looking for the situation where low becomes less than equal to high. We spoke about all of this in detail. We always search in the middle, so everything remains the same, but clearly the definition of found has to change. So I'm going to say, look, my found definition is, well, remember the first point where I exceed, and always the search is happening at the mid location. So I just go and say altitude, say altitude, say mid is greater than a thresh, and now this is an and condition important, so I just go and say altitude, let's say mid -1 is less than equal to a thresh. So this is like saying in words that, look, my altitude at the mid location has become more than the threshold, and at the same time the altitude, so this is altitude at mid -1, which is the previous location, has not exceeded the threshold. Remember, we are strictly looking for the case, for the index where the threshold has been exceeded. So if I found the value that I was looking for, the search is going to abort. But if not, I will have to update my low and let's say midpoint, low and high pointers. So the question I ask myself is, well, is my altitude at the mid level? Is my altitude, let's say, at the midpoint, less than or equal to a thresh, right? So if this is the case, remember, this is a situation where I know that my threshold must be ahead of me, which means I should be discarding the left half of the list and searching the right half. So I'm going to say, well, in this case, low is equal to mid +1. And if that doesn't happen, I know that my threshold must be behind me. Hence, high is equal to mid. Since I've handled, let's say, the extreme condition separately, all I need to do is to say, well, return, say, so outside the while loop, let's just go and say return, uh, return mid. So mid could be, the index that has been found. Otherwise, I return a -1. So, that's all I needed to do. Let's just test this code. Let's see it's working. And then we will come back and analyze this code a little bit more carefully for slightly more detailed points. So let's say I have a list here called altitude, which has item 0, say 11, say 20, 29, Um, Now this is just an example list: 38, 47, 61, 64, 70, and 76. I just an example list. Let's say I set my A thresh to say 10, and I just want to find out, the IDX is, let's say, binary search. Okay, so IDX is, say, binary. What's the name of a function here? Let me be careful here. Binary search altitude. So binary search altitude, and I'm going to pass in these lists altitude as an argument, and I'm going to pass A thresh as an argument. But of course, to run this, I must first make sure this code is run once. And then I am in a position to run this as well, right? So of course, to sort of be clear, let me just put the print of this index here, print IDX. So when I do this now, when I search for, let's say, 10, I get 1, which is clearly right, because remember, altitude 0 is always 0. It's at point item 1 that I first exceed 10. So that's why the value given is 10. Let's try a few more examples. Let's say I try, maybe 25. So if I were to try 25, my value that I get back is 3, 0, 1, 2, 3. 29 is where this would have first, let's say, exceeded. And indeed, that is the case. Let's try, say, 50. So when I do 50, well, I get 6, because 0, 1, 2, 3, 4, 5, 6. 6 is where the threshold of 50 is first exceeded. 61 is more than 50. 47 is not. Now, I urge you to think carefully about this, see how the low and high pointers are moving, because that gives you much more insight. But, here we have done this in the past, so I'm just kind of, let's take one more example. Let's say I give threshold to be, say, for example, say maybe 75. So if I were to give 75, well, my answer that I get is 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If I were to give anything more than this, let's say 90, I am expecting a -1, and indeed that's what happens. So it's like saying that, look, none of these values exceeded 90. So really, quite similar to what we had done earlier. Now, at this point, I really urge you to think carefully. If you want to, can put prints to see how low and high pointers are moving. But this is kind of similar to what we had done before. Let's take a few more examples where we have slightly more involved lists. Let's say I set the threshold to 50, but I have, let's say, several items that are exactly equal to 50. And say, so the situation is, let's say something like this, say 50, 50, 50, 50, and say 60. So notice this list is a non-decreasing, values. However, there are repeated values, and that repeated value happens to be exactly equal to the threshold. Now, when I run this piece of code, notice my answer is 9, because remember, the problem statement is, what is that first index at which I exceed the threshold? So that happens at 60. That's why the answer is indeed 60. Now let's say I have a repeated value just a little bit lower than the threshold. Well, in that case, in this case, when I run this, I get the answer as 8, because once again, remember, the repeated values are, below the threshold, and I just look at the first value where I do exceed the threshold, which is 51. Let's take a slightly inverted case here. Let's say I have 3 51s. Which is repeated just before, this is just higher than threshold. Well, the answer is going to be 6, because 0, 1, 2, 3, 4, 5, 6. This is where I first go and exceed 50, and that's exactly what I was looking for. So these repeated values are interesting, because that is kind of testing the code a little bit carefully, and making sure that everything is working correctly. So I hope this has been clear. So before I wrap this up, let's try to understand some pieces of code a little bit more carefully. Found is defined as altitude mid greater than a threshold, and less than altitude mid -1 less than equal to a threshold. Once again, why not greater than equal to here? Well, because remember, we are looking for a strict greater than. And why not less than? Because, well, again, the same reason, right? So we have to be careful with these small little things, because that influences the code. Now, one question that might come up is that what happens if mid were to become 0? So for example, here, if I were to do found is altitude mid greater than a threshold, and altitude mid -1 less than equal to a threshold, what happens if mid is 0? Because this would be altitude -1, which is the last value on that list. Remember, -1 means the last value. But then, we have already preempted this situation. So the condition here is, remember that my altitude 0 is always 0 and A threshold is strictly positive, which means that let's say the extreme scenario that we are looking at is A threshold is between the 0th and the first item. So when you run the binary search, you will basically find this value before this condition hits. There's a trivial, let's say, extreme case. If my list altitude had only 2 values, then I could run into problem. But we are assuming that altitude list has many more values, and hence, we kind of let it be. When we update the mid value, again, we are looking for A altitude less than equal to A threshold. So I move forward. Remember, even if my altitude is equal to A threshold, right? If my altitude is equal to A threshold, the threshold crossing has basically happened after the present value, which is why this is less than equal to, and hence I will move my low to mid +1 because I'm going to search afterwards, right? So again, these little things, they're related to the problem definition. Do think about it. Do, let's say, put some prints, and very happy to discuss. But you see how binary search is helping us. Now, before wrapping this up, we can clearly see that this problem could have been solved also with linear search. In fact, the code would have been a lot simpler. All I have to do is to just go and search every item if I've gone more than the thresholds. But binary search is in fact better than linear search for the same exact reason that we have seen earlier, that binary search is a lot more efficient. Basically, a flight path of, let's say, 10,000 items can be analyzed in at most 14 steps. That is log 2 of 10,000. But the flip side, as we are seeing, well, the code has to be written carefully, quite easy to make subtle mistakes, which can lead us to wrong solution. On the other hand, linear search is less efficient. However, the code is a lot simpler. In fact, that's some kind of a general rule that the moment we start seeking more efficient solutions, we got to be more careful with the way the code is written. But obviously, that is something we got to be ready for, because remember, efficiency is something we desire, but correctness cannot be compromised. I hope you found this interesting. Do look at our website www.ybyte.in to find more such content and more such videos which can make your learning of algorithms come alive. Take care. Thank you so much. Bye bye.